Okay. There are two types of angles. One is angle which we measure in degrees, and the other one which is in radians. These are the two kinds. Degrees in when you write 360 degrees, 180 degrees, you write this small o on the above.
Yeah.
Radians is when it is in terms of pi. To convert degrees into radians or radians into degrees, 1 pi radian is equivalent to 180 degrees. This is the conversion. This is important to remember.
Okay.
180 degrees is equivalent to 1 pi radian.
Is that a C or a circle?
Well, it is just represented as C. So overall, you can say 1 pi radian is 180 degrees. Can you tell me how much will be 360 degrees?
2.
2 pi.
Mm-hmm.
So how much will be 30 degrees?
1/6.
1/6 of pi, which is pi by 6.
Yeah.
So pi is 180. So
Yeah.
this is important in order to convert degrees into radians.
Yeah.
This is the conversion formula. So let's say we're talking about arc.
Uh-huh.
Let's say this arc is making an angle of theta degree, theta radian. At the center.
Yeah.
And the circle has a radius of r. This is theta. Arc length, which means
R times theta.
this length.
Yeah.
R times theta. Theta is in what? Is it degrees?
No.
It is in radians. That is important to remember. And what is the difference between arc and a sector?
A sector is a line.
So it's like an arc only, but if you join with the center.
Yeah.
So this is an arc, but if you join the endpoints, you'll get the sector.
Yeah.
Let's say the angle at the center is theta only, radius is r.
Uh-huh.
So it's like a pizza, sector means. So area of the sector.
Ooh.
Okay, first things first, let's understand the perimeter.
Okay.
Perimeter of the sector. What do you understand by perimeter in general?
The length of boundary.
Yeah. Can you guess what will be the length of this boundary of this sector?
2R plus R theta.
Theta is in radian.
Yeah.
So r into theta plus 2. This is about the perimeter of sector. Area of sector is, you have to remember this, half r square times theta.
Uh-huh.
Theta is still in radian.
Half R squared.
Half r square theta.
Yeah.
Okay, let's use some imagination. Theta is the middle angle, right? At the center.
Yeah.
Let's say this angle increases and becomes 180 degrees.
Yeah.
The shape becomes
Huh?
let's say the angle at the center is increasing.
Yeah. Oh, semicircle.
Yeah. When the angle becomes 180 degrees, it becomes a semicircle.
Yeah.
We already know that length of the arc is r times
R times beta.
theta.
Mm-hmm.
Theta in this case will be
180
theta is in
radian.
radian. 180 degrees means how many radians?
One.
1 pi.
1 pi.
Correct.
Yes.
So r times 1 pi is pi r. So this is the length of the semicircle.
Uh-huh.
We know that for a full circle it will be 2 pi r length.
Yes.
For half circle it will be half of that pi r. Okay.
Yeah.
And area of sector is
Area of sector is half r squared.
half r square theta. Let's say if theta is 180 degrees, theta will be here.
Yeah.
The formula becomes half r square times
180.
180 is pi.
Yeah.
So pi r square divided by 2. For a full circle it will be,
Pi r squared.
that is the area of circle,
Yes.
which you might know already. So these are the formulas. One is area and the other is arc length. Area of sector and arc length.
Yes.
And what is the radius?
It is the from midpoint to circumference straight line.
Okay, first let's discuss about circle. What is it? That is the chapter name, right? What is a circle?
It's a 2D shape.
Well, it is a 2D shape. Triangle is also 2D shape. But what makes it a circle?
It's round. It's not made of straight lines.
We know that circle will be like this.
Yes.
This is called, this point is
Midpoint.
center.
Yeah. From center to circumference is 1 radius.
Radius. So circle is actually collection of those points. Collection of
Yeah.
points in a plane such that all of them are at equal distances from a fixed point. So it's like, let's say there is a fixed point here,
Uh-huh.
and all of those points are at fixed distance.
Yeah.
That makes it a circle. So this fixed point in this definition is center, and this length is radius.
Ra-
So that is what it means by circle. So this is about radius, and diameter is
of 2 radius.
d is equal to 2r, twice the radius. It passes through, diameter passes through
Center.
point,
Center.
center. Sector we just discussed.
Yes.
In sector also there are two types, minor and major. Minor sector is when it is small or big.
Small.
Small. Area formula still remains the same.
Mm-hmm.
Half r square times
Theta.
theta. You know what is theta and in which degree or radian? That is all clear.
Yeah.
The formula is still same for this one and this one. Just remember this. It will be easy.
Yes.
Okay, let's talk about now chord in a circle. Do you know what that is?
It's a line it's the line cutting a circle that doesn't go through the midpoint.
The thing is, it is a line segment
Yes.
joining any 2 points on the circle. Let's say there is a circle like this. You join any 2 points. If you join them, this line segment is called a chord.
Yes.
It is not a line. Line will be something like this. Line segment is finite. Line is not. This is called a chord, but this line segment is called a chord, but this line is called secant. Secant to the circle. So you understand the difference between chord and a secant?
Yes.
So when we talk about diameter, we know that it passes through the center. Diameter in a circle is the largest chord in a circle. So it's like this is a chord, correct?
Yes.
This is also a chord.
Yeah.
So let's say center is here. This line segment is the
Yeah.
largest.
Yes.
How many diameters can a circle have?
Infinite.
Infinite. So by the diagram we can say that it is the largest.
Yes.
So that's about that. And what is a tangent?
Um.
Let's say there is a circle like this.
It.
Let's say there is a secant line.
Okay.
What will happen? What will happen if you bring this line towards the left? It will come. It will come like this.
Yes.
But if you do further, it might go here.
Yes.
But in somewhere in the middle, it will pass through just a single point.
Yes.
That is called a tangent.
Oh.
So it touches the circle at how many points?
1 point.
At a single point.
Yes.
So what is the difference between secant and a tangent?
The tangent touches at single point.
And secant,
Passes through two.
2 points. Both are lines only, not line segment. Okay.
Yeah.
So that is the only difference between secant and tangent.
Yeah.
And let's learn about this tangent a bit more. There are some interesting properties when it comes to tangent. Let's say this is the tangent.
Yeah.
Here, let's assume the center is here.
Yes.
Let's say this is the point of intersection
Okay.
between tangent and
Circle.
circle. P is point of intersection between tangent and circle. If you join center with the point of contact, this P, this length is radius, and let's say this line is T, tangent line,
Yeah.
or let's say line L.
Okay.
CP is perpendicular to line L. This is important. These two things. So basically this will be 90 degrees. 90 degrees. And the length is just the radius.
Yeah.
And that's it. So these are some basics which we need to keep in mind.
Yeah.
Yeah, I think these are the basic terms. Let's jump into theorems. What is the first theorem which you learned?
Actually, I have two. The angle subtended at an arc. The angle subtending an arc at the center is double angle subtended at the circumference.
Yeah, basically, let's say there is an arc like this.
Yeah.
Let us consider this minor arc.
Yes.
Center of the circle is here.
Yes.
Let's say this arc is subtending an angle of theta degrees.
Okay.
So the same arc will be subtending an angle of
2p.
twice that.
Yes.
The center.
Yeah.
Twice the angle it makes at any point on the circle.
Yeah.
So at center. So let's say at the center, this is 15 degrees. How much will be this angle?
7.5.
7.5. So this is the first theorem.
Mm.
Yeah. Second theorem is
The angle at the circumference in a semicircle is a right angle.
before we go there, let's try to understand some things.
Okay.
Let's say the same minor arc
Okay.
is subtending an angle of, let's say, 30 degrees at point P. Let's say there is another point Q which is on the circle,
Uh-huh.
some random point. How much will be this angle?
30.
30. So angles are same by the same arc. At any point on the circles.
Angles. Angles are same.
But you have to be careful. It is when the same arc, when it is subtending an angle of 30 degrees, here, 30 degrees on the major arc.
Yes.
Minor arc, angle at major arc is 30 degrees.
Okay.
But the same arc on the major arc, this is the angle.
Okay.
How much will that be?
Um,
So the same minor arc,
Yeah.
one minor
180 minus 30.
180 minus 30. So basically, what that means is it is not 30 degrees. Not 30 degrees. Angle is equal to supplementary 180 minus 30. So that is 150. Can you tell me the same arc? How much angle does that make at the center?
Huh?
How much angle does that make?
Oh, that is,
This blue angle?
yeah, 60.
60. Good. So yeah.
Same arm.
And the third theorem is cyclic quadrilateral. You know what that is?
No.
Cyclic quadrilateral is a quadrilateral which is inside the circle. Vertices of the quadrilateral
Okay.
circumference so in the earlier shape, this one. Let's say this is A, B, C, D.
Yeah.
So ABCD is a cyclic quadrilateral.
Yep.
So it could be any shape, but we should make sure that the vertices lie on the
Yes.
ABCD. This is a cyclic quadrilateral.
Okay.
Let's say the center is this.
Yeah.
PQR. This is a cyclic quadrilateral.
Because it's not touching the circumference.
All 3 points are already on the circle.
Yes.
But still the fourth vertex is
Not on the circle.
not on the circle.
Mm.
So even if it is like this, is it a cyclic quadrilateral?
No.
All four must lie on the circle, not inside or outside the circle.
Yes.
This is like point C here, this one,
Mm-hmm.
inside the circle.
Okay.
And let's say this is PQRS. Point
Yeah.
S is
Outside.
outside the circle.
Uh-huh.
And when it comes to cyclic quadrilateral, the sum of opposite angles
Mm-hmm.
must be
180.
supplementary or 180. So in the earlier question, this arc was making 30 degrees. We have said that this will be 150.
Yes.
And let's say this. So B and D are opposite pairs.
Yeah.
What else is opposite pair?
AC.
A and C. So let's say A is 15 degrees. What will be the angle C?
165.
165 degrees. So that is what it means. Sum of opposite pairs of angles. And this is valid only in what type of quadrilateral?
Cyclic.
Cyclic quadrilateral. Not just any normal quadrilateral. Cyclic. Okay. Okay, I'll tell you one small concept.
Okay.
Square. How much will be this angle if it is a square?
90.
90. And what about this angle?
90.
So notice something. Sum of opposite angles are
X.
Equal to 180.
square. Opposite angles add up to 180.
180.
So that means all squares are what type of quadrilaterals?
Cyclic.
All squares are cyclic. Can you say about rectangle? What can you say?
Yeah.
Rectangle also same. So that means they all fit inside a circle.
Yeah.
Let's say if I draw a random shape. Let's say a square or rectangle. What I know is the vertices ABCD must be part of some circle.
Yeah.
So that circle will pass through the vertices like this.
Yeah.
This angle is 90 degrees.
Mm-hmm.
So this is about number 3, third theorem.
Yeah.
And the fourth theorem is, it is simple only. Fourth one is angle subtended by diameter
Uh-huh.
on that thing. What do I mean by that is, let's say there is a circle and let's say this is the diameter. It passes
Okay.
through
C.
center. So what that theorem says states that is, read this thing. Done?
Yeah.
So this diameter makes an angle of 90 degrees on the circle.
Yeah.
This angle will be 90 degrees. This is a fact.
Okay.
Can you tell me how much will be this angle?
90 degrees.
If one is 90, other also becomes a 90.
Yeah.
Okay. Now let's look at this rectangle. This angle is 90 and this is also 90.
Yeah.
What can you say about AC? AC and
9.
ED are
Same.
same, but what are they exactly? How are they related to that circle?
They are subtended by diameter.
So AC and BD become diameter. Diameters of that circle. So that is the concept. For square also, AC and BD will be.
Diameter.
Yeah. If you consider BD, it will be something like this. We know that these two angles are also 90.
Yeah.
So that makes it a diameter. So I hope it is clear.
Yes.
And some basic things, let's say if it is a circle, let's say this is the point.
Yeah.
This entire angle is how much?
No. Yeah.
360 degrees. So half of it will be for semicircle
180.
180. So these are basic things. 360 degrees means how much pi?
2.
2 pi, right?
Yeah.
And arc length formula was
Arc length R theta.
theta. Theta in this case was
180.
here.
Pi. 2 pi.
So arc length, which is nothing but the circumference of the circle, is
2 pi r.
so 2 pi r. So these are some basics. Let's do